Vaults containing gas regulators are classified according to the National Fire Protection Association, or NFPA 58. Specifically, Section 3.3.7.4 of NFPA 58 dictates the classification. The appropriate classification for these vaults is Class 1, Division 2. This classification signifies that the vault is considered a hazardous classified location due to the potential presence of flammable natural gas. However, the hazardous area is not typically present under normal operating conditions. It is more likely to occur during abnormal conditions such as a gas leak or during maintenance procedures. Furthermore, these vaults are generally not occupied. Entry is restricted to authorized personnel who require access for maintenance or inspection purposes. In summary, vaults containing gas meters and regulators beneath sidewalks are classified as Class 1, Division 2 hazardous locations due to the potential for flammable gas leaks and the need for occasional maintenance. Therefore, the vaults in question would be classified as Class 1, Division 2 hazardous locations. Understanding the classification of these vaults is crucial for ensuring safety and compliance with fire codes. The Class 1 designation indicates that the hazard involves flammable gases or vapors in air that may be present in sufficient quantities to produce explosive or ignitable mixtures. The Division 2 designation signifies that the hazardous materials are not normally present in the area but may be present for a short period of time due to accidental rupture or breakdown or due to abnormal operation of equipment. This classification has implications for the type of electrical equipment and wiring that can be used in the vault. Equipment must be designed and installed to prevent ignition of the flammable gas. This may involve using explosion-proof enclosures or intrinsically safe circuits. Additionally, personnel working in the vault must be trained in the hazards of flammable gases and the appropriate safety procedures. They should also use appropriate personal protective equipment such as gas detectors and flame-resistant clothing. Regular inspections of the vaults are necessary to ensure that the gas meters and regulators are in good working order and that there are no gas leaks. Any leaks should be repaired promptly to prevent the buildup of flammable gas. Ventilation is also important to prevent the accumulation of flammable gas. The vault should be designed to allow for natural ventilation or be equipped with mechanical ventilation systems. The ventilation system should be designed to exhaust any flammable gas that may be present. Signage should be posted to warn of the hazardous nature of the vault and to restrict access to authorized personnel only. The signage should also include emergency contact information. The classification of gas meter vaults as Class 1, Division 2 hazardous locations is a critical safety measure to protect people and property from the hazards of flammable gas. By understanding the classification and implementing appropriate safety procedures, the risks associated with these vaults can be minimized. The NFPA 58 standard provides detailed guidance on the design, installation, and maintenance of gas meter vaults in hazardous locations. It is important to consult this standard to ensure compliance with all applicable requirements. The specific requirements for Class 1, Division 2 locations are found in the National Electrical Code, or NEC, Article 500.5. The requirements include the use of equipment that is approved for Class 1, Division 2 locations, wiring methods that are suitable for hazardous locations, and grounding and bonding requirements to minimize the risk of electrical shock. Some examples of equipment that may be used in Class 1, Division 2 locations include explosion-proof lighting fixtures, intrinsically safe instruments, and sealed conduit systems. Explosion-proof equipment is designed to contain any explosion that may occur within the enclosure and prevent it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to limit the amount of energy available in the circuit to a level that is below the ignition energy of the flammable gas. Sealed conduit systems are designed to prevent the migration of flammable gas into the conduit. Regular maintenance of the gas meter vaults is essential to ensure their continued safety. Maintenance activities should include inspecting the gas meters and regulators for leaks, checking the ventilation system, and testing the gas detectors. Any deficiencies should be corrected promptly. In addition to the requirements of NFPA 58 and the NEC, there may be local codes and regulations that apply to gas meter vaults. It is important to check with the local authorities to ensure compliance with all applicable requirements. The classification of gas meter vaults as Class 1, Division 2 hazardous locations is a complex issue that requires careful consideration of all applicable codes and standards. It is important to consult with qualified professionals to ensure that the vaults are designed, installed, and maintained in a safe manner. Furthermore, it is worth emphasizing the importance of proper training for personnel who work in or around these gas meter vaults. Training programs should cover the following topics. Firstly, the properties of natural gas and the hazards associated with its presence in confined spaces. Secondly, the classification of hazardous locations and the requirements for electrical equipment in such locations. Thirdly, the use of gas detection equipment and personal protective equipment. Fourthly, emergency procedures in the event of a gas leak or other incident. Fifthly, the importance of regular inspections and maintenance. By providing comprehensive training, employers can help ensure that their employees are aware of the risks involved and are prepared to respond appropriately in the event of an emergency. In addition to training, it is also important to have a written safety plan in place that outlines the procedures to be followed in various situations. The safety plan should be reviewed and updated regularly. Communication is also key to maintaining safety in and around gas meter vaults. Workers should be encouraged to report any potential hazards or concerns to their supervisors. There should also be a clear system for communicating emergency information to all affected personnel. The use of technology can also enhance safety in gas meter vaults. For example, remote monitoring systems can be used to detect gas leaks and other problems. These systems can provide early warning of potential hazards and allow for prompt corrective action. Another important consideration is the security of the gas meter vaults. The vault should be secured to prevent unauthorized access, which could lead to vandalism or tampering with the gas equipment. Security measures may include locks, alarms, and surveillance cameras. Finally, it is important to remember that safety is an ongoing process. Regular reviews of safety procedures and practices are essential to identify areas for improvement. By continuously striving to improve safety, we can help prevent accidents and protect people and property from the hazards of flammable gas. The classification of these vaults is related to the potential for explosive atmospheres. An explosive atmosphere is defined as a mixture of flammable substances in the form of gas, vapor, or dust with air under atmospheric conditions in which after ignition combustion spreads to the entire unburned mixture. The presence of an explosive atmosphere necessitates specific safety measures to prevent explosions. The NEC provides guidelines for electrical installations in hazardous locations, including requirements for equipment, wiring, and grounding. Article 505 of the NEC covers zone classifications, which are similar to division classifications but used internationally. It's also important to understand the concept of lower explosive limit, or LUL, and upper explosive limit, or UL. The LEL is the lowest concentration of a gas or vapor in the air that will burn, while the UEL is the highest concentration that will burn. An explosive atmosphere exists only when the concentration of the flammable substance is between the LEL and UEL. Gas detectors used in these vaults are typically calibrated to alarm at a percentage of the LEL, providing an early warning of a potential explosive atmosphere. Proper ventilation is crucial in preventing the buildup of flammable gases and maintaining a safe atmosphere. Ventilation can be natural, relying on airflow through openings in the vault, or mechanical, using fans to force air circulation. Mechanical ventilation systems should be designed to ensure adequate air changes and prevent the formation of dead spots where gases can accumulate. Maintenance of ventilation systems is essential to ensure their proper operation. Regular inspections should be conducted to check for obstructions, corrosion, and other problems that could impair airflow. In addition to gas detectors, flame detectors can also be used to provide an early warning of a fire. Flame detectors are designed to sense the infrared or ultraviolet radiation emitted by flames and can trigger an alarm. The selection of appropriate flame detectors depends on the specific characteristics of the gas or vapor that is likely to be present. Another important safety measure is the use of non-sparking tools in hazardous locations. Sparking tools can ignite flammable gases or vapors, causing an explosion or fire. Non-sparking tools are made of materials that do not produce sparks when struck against metal surfaces. These tools should be used whenever working on gas equipment in the vault. Grounding and bonding are also essential for preventing explosions and fires. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of the electrical system together, ensuring that they are at the same electrical potential and preventing sparks. The NEC provides detailed requirements for grounding and bonding in hazardous locations. Another key aspect of safety is the proper selection and installation of electrical equipment. Equipment used in Class 1, Division 2 locations must be specifically designed and approved for use in those locations. This equipment is typically enclosed in explosion-proof housings or is intrinsically safe, meaning that it cannot produce enough energy to ignite a flammable gas or vapor. The installation of electrical equipment in hazardous locations must be performed by qualified personnel who are familiar with the requirements of the NEC and other applicable standards. Proper wiring methods, sealing techniques, and grounding practices are essential for ensuring the safety of the electrical installation. Regular inspections of electrical equipment are also necessary to identify any signs of damage, wear, or corrosion. Damaged or defective equipment should be repaired or replaced promptly. In addition to the technical aspects of safety, it is also important to address the human factors. Human error is a significant cause of accidents in hazardous locations. Training, procedures, and communication can help to reduce the risk of human error. Workers should be trained to recognize potential hazards, follow safe work practices, and report any concerns to their supervisors. Clear and concise procedures should be developed for all tasks performed in the gas meter vaults. These procedures should be reviewed and updated regularly to ensure that they are effective and practical. Effective communication is essential for coordinating work activities, sharing information about potential hazards, and responding to emergencies. Workers should be encouraged to speak up if they have any concerns or questions. Finally, it is important to foster a strong safety culture in the workplace. A safety culture is a shared set of values, beliefs, and attitudes about safety that is reflected in the way people behave. A strong safety culture can help to prevent accidents and create a safer working environment. Gas meter vaults located under sidewalks, housing regulators and meters, require meticulous attention to safety protocols due to the inherent risk of natural gas leaks. These confined spaces, often accessed for maintenance and inspection, demand stringent adherence to NFPA 58 standards and the NEC. Classifying these vaults as Class 1, Division 2 hazardous locations is a proactive measure to mitigate potential hazards. This classification mandates the use of explosion-proof equipment, intrinsically safe systems, and specific wiring methods, all designed to prevent ignition in the presence of flammable gas. Ventilation systems, whether natural or mechanical, play a crucial role in dispersing any leak gas, preventing the formation of explosive atmospheres. Gas detectors, calibrated to alarm at a percentage of the LEL, provide early warning of potential leaks, allowing for prompt intervention. Regular inspections and maintenance are paramount, ensuring the integrity of gas meters, regulators, and ventilation systems. Furthermore, personnel working in these vaults must undergo comprehensive training, covering gas properties, hazardous location classifications, the use of safety equipment, and emergency procedures. A written safety plan, regularly reviewed and updated, serves as a guide for safe work practices. Security measures, such as locks and alarms, prevent unauthorized access and potential tampering. The integration of technology, like remote monitoring systems, enhances safety by providing real-time data on gas levels and equipment status. Non-sparking tools are essential when working on gas equipment, minimizing the risk of ignition. Grounding and bonding practices prevent electrical sparks, further reducing the likelihood of explosions. By meticulously adhering to these safety measures, the risks associated with gas meter vaults are significantly minimized, safeguarding both personnel and the surrounding environment. A proactive safety culture, emphasizing training, communication, and continuous improvement, is essential for maintaining a safe working environment in these hazardous locations. Continuous monitoring and upgrades of safety systems are crucial, adapting to evolving technologies and regulatory requirements. This holistic approach ensures the ongoing safety and reliability of gas distribution infrastructure in urban environments.